Yes, we are live now. Power cut was there, beta. Sudden power cut was there. Yes, sudden power cut was there. Because of that, that problem came. Let's go back to work, please. Yes, Maya, good morning, beta. Jotam, good morning. Tarun, good morning. Yes, Anu, good morning. Now look, beta. So we were exactly discussing about that numerical and 4.2 ohm we got. Now here, what they are talking about, two wires made of German silver are taken such that the length and area of cross section of second wire are twice and thrice respectively those of first wire. Wow. Twice and thrice respectively those of which wire? Those of first wire. Those of first wire. If the resistance of the second wire is 12R, find the resistance of the first wire. So two wires are made with German silver. Note down this one. Two wires are made with German silver. Note down, silver is the best conductor of electricity. Na? So here two wires are made with what beta? Two wires are made with German silver. Okay. Are taken such that length and area of cross section of second wire are twice and thrice respectively. So length is twice of previous one and length is twice of previous wire. Same wire is taken. Now, see, two wires made of German silver. Both are made with same German silver. Both are made with what? Same German silver. Try to understand the question. Both wires are made with same German silver. Okay. But one length is, the second wire length is two times of the length of the first wire, and its area of cross section is three times the area of cross section of the previous one. Understood? So this is exactly the two cases given. Now what they are telling, that if the resistance of the wire is 12R, what is the resistance of the wire given? 12R. Okay, we will write it ohm. Find the resistance of the first wire. So first case, this is our equation beta. Second case, the second length is exactly 2 times. Now second, resistance of the wire is 12 ohm. So second time resistance of the wire given is 12 ohm. What is the resistance of the wire in the first case? The resistance of the wire in the first case is coming as 18. But we need to solve, it is very complicated part. Correct now? So let's solve this question because we are not understanding what they are giving. So let's take in our own way. We are going to understand in our own way. Okay. Good morning, Gopika. Today late. Ashwita was one who has exactly said me hi first. After that, Jotam. Now today many students are late. And Kartika, Kavya is there. Kartika I am not seeing. Jasmita is there. Okay. Some children are not at all attentive. Today I am going to talk to them. Yes, Ashish. Yes, Satya, good morning. Now listen, beta. Our work we are going to start. So first resistance and second resistance. Second resistance given how much beta? 12 ohm. So length of the wire is taken as L1. Here, length of the wire is L2 is 2 times of L1. Area of cross section here is A1. Now here area of cross section is 3 times of A1. Understood? Now we don't know what is the resistance. Understood? Since both the wire is made with what beta? Both the wire is made with German silver. Therefore, its resistivity will remains same. Its resistivity will remain same. Since both of them are made with what, beta? Thank you for liking the class. Since both of them are made with what, beta? Both of them are made with what? German silver. So its resistivity remains same. Its resistivity will be remaining same. I hope you might have understood this one. So its resistivity is not going to change. Its resistivity remains the same. So now look here. What we are going to do, we will find case 1 and case 2. And here R1 is equal to rho L by A, L1 by A1, equation 1. R2 is equal to rho L2 by A2. This will become equation 2. Dividing equation 1 by 2. Dividing equation 1 by equation 2. So when you will divide equation 1 by equation 2, what and all work you will do, beta? R1 is what for you? We don't know. But what is R2? 12. Now beta, rho remains same, but L1, A1 same. But here rho, this part is coming, L2 is how much, beta? L2 is 2 times of L1 and A2 is 3 times of A1, correct na? So here L2 is 3 times of, yes. So now what we are going to do, this and this will get cancelled, this and this will get cancelled. So R1 by 12 is equal to 1 by 2 by 3. Done beta? So R1 will be equal to 12 will go multiply with 3 by 2. So here how much it is coming? 6. So this is coming as 18 ohms. How much answer is coming, beta? 18 ohms. What is the answer coming? Mahavir, what? Ammeter is a device that is connected in the circuit in series to find the amount of current flowing in the circuit. Okay. Ammeter resistivity is less, amount of flow of current will be high. That's the work of ammeter. That's the work of ammeter. Its symbol is A. 18 ohms. I hope everybody understood this. How to solve this question? Come on, check, children. This is exactly now you understood now how to solve this question. Everyone very comfortable how to solve this question, children say? Are you all comfortable that yes, we can solve this question? Super, Vishwa. So now look here. We will go for the next part. Note down. Note down. So this is exactly the cases. Let them write. Some children are writing. Yes. Hello, Aditya. So this is exactly what we have to do, beta. Simple way we have solved. First resistance, second resistance, and the ratio we have taken and we have solved it. Thank you for liking the class, beta. So now look here. Shall we go for the next one, beta? Ready? Jivitan written. Note down. Dividing equation 1 by equation 2. So I have solved it. After that, I have written here, beta. After that, I have written here, and this is the final part. So first resistance is coming as, good morning, beta. Huh? Good morning. So now listen, we will go for the next one. Let's check this one out, beta. We are going to solve the next part of the question. So now we are going to talk about the contents that is exactly associated with it. So now we are going to talk about the connecting wire in an electric circuit are made up of copper and aluminum. So mostly what type of, oh, bless you. So now look here, the connecting wire in an electric circuit are made of copper and aluminum. Why we are not using silver? We are not using silver because it is exactly the best conductor, but it is exactly, yes, copper and aluminum is there, beta. We are not taking silver because silver is very expensive, and see, for kilometers and kilometers we cannot use silver now. And the second important thing is it is having high resistance or low resistance. Low resistance. Low resistance, which makes it very, very unique. But bless you, beta. Bless you, Aditya. So now listen. So here you need to understand that low melting point is there. That means oxidation state is very low. Means the moment more amount of current, see, because its resistance is less, low amount of, means if less amount of current is also passing through it, it will get heated up. And the moment it will heated up, what it will do? It will melt. The moment it will melt, yes, it is expensive also. Absolutely correct. Expensive and oxidation state. These are the two things that makes it unique. Okay. So now we are going to talk about, see, electric current passes through aluminum and copper very, very easily. One thing. Second is its oxidation state is quite high than silver. Understood? Resistivity is more than silver. Resistivity is more than silver. Yes, absolutely correct. So now we are going to go and talk about silver is the best conductor but lowest among all metals, but thus connecting wire in electric circuit must be made with silver. However, we are using this because they are exactly having low metals and cheaper than silver. That's what all people talked about. So therefore connecting wire is made with copper and aluminium. Now filament of electric bulb is made with tungsten metal. Filament of electric bulb is made with which metal, beta? Tungsten metal. Okay, ma'am. Diamond, carbon. So now look here. Tungsten being metal has high resistivity. So it does not burn even at high temperature. So melting point of tungsten is how much, beta? The melting point of tungsten is very high. 3380 degrees Celsius is the melting point of tungsten. How much? 3380 degrees Celsius. W. Absolutely correct. And you know what? In incandescent lamp we are using, but tungsten is having one very big defect. Can anybody tell me what is the, hi Shivam, can anybody tell me what is the defect of tungsten wire? Anyone tell me what is the defect of tungsten wire? I know the melting point is 3380 degrees Celsius, but why melting point of, see, why, what is the problem with tungsten wire? Anyone say, what is the problem with tungsten iron? Thank you, Aditya. Bless you, beta. Now listen, what is the problem with tungsten wire? Use of more energy? No. Hey, it will allow current easily. So only we are using tungsten wire. It, see, what is the purpose now? The moment current will flow through it now, it will become red hot. It will become red hot, and you know what? The moment it will become red hot, it will start glowing and giving light. So only we are using tungsten wire. Understood? Why we are not using alloys? We are using tungsten wire. In fact, in less temperature itself, it will start glowing. So only still now we are not using that. High resistivity, everything. I am accepting all your answers, but one biggest answer is, you know what, beta? Heating effect is there, high temperature is there. What answers you will say? Absolutely correct. But you know, did you check the tungsten wire reaction with oxygen? Did you check the tungsten wire reaction with oxygen? So only all the bulbs are there, na? Yes, oxidation. All the bulbs are there. You might have seen that the bulbs are exact. Thank you for liking the class, beta. Bless you all. So the thing here is, yes. So definitely one thing is there. Check everyone. Check everyone. I have asked you one question, but I am going to give you one slight indication that my what you called, my people are running. I'm not running. I'm only teaching. It prevent, no beta. The thing here is, you might be seeing that the tungsten wire is kept under glass bulb, transparent glass. Correct now? What can be the reason behind it? Now to different type of what you call, yes, what is the reason behind it? The only one reason is if you will expose it to atmosphere, oxygen, it will oxidize. It will oxidize. So what they are doing it, they are safing it inside. Yes. So what is exactly done here is it will exactly oxidize. So this answer I want in second session. This answer, a very perfect answer I am wanting in second session. Why tungsten? See, if tungsten is exactly using less heat, less current, and it is getting red hot, it is giving heating effect. You might have seen old bulbs, na 100-watt bulbs. If it will be glowing means 200-300-watt bulbs will be there. If it will be glowing means you will get heated. You will feel heat. Correct, na? Because it is exactly glowing with red hot. Understood? So heat is coming. But why it is one defect is there? That defect I want from everyone. So just check. Yes, it blocks the oxygen, and understood, it blocks the oxygen. That's the most important thing. Understood, it is blocking what? Oxygen. So now we are going to talk about the next part. Now look at it. The resistivity of nichrome. Then we talked about nichrome. What is nichrome? Nichrome is an alloy. It is made with nickel, chromium, manganese, iron, and it is exactly very important alloy. What is that important alloy is? The important alloy, why? Because it will oxidize at high temperature. It is oxidized at high temperature, and it is having high resistivity. Yes, absolutely, Mahavir. But here, one thing is there, it is consuming high. That's not, see, you need to understand one thing here. Just go to one specific point. Yes, Ashweta, oxidation, tungsten. So, nitrogen and argon are used to prevent oxidation. Yes. You know what? Inside the bulb now, what they are using? Nitrogen and argon. See, nitrogen is exactly present in nature in very high amount. Understood? So it is non-reactive gas. So what we are doing is either inside the glass bulb we are putting nitrogen, or we are using argon. Argon is a noble gas. Again, it is non-reactive gas. Argon is what? Noble gas. Again, it is non-reactive gas. So both the gases are exactly what? Non-reactive. I hope nitrogen and argon. Yes, children. That's absolutely correct. Understood or not? Thank you so much, everyone. But the most important thing here is कि you need to understand this part, that कि whenever we talk about tungsten, tungsten must be protected from atmosphere. Why? Because the moment it will come and expose with atmosphere, the oxygen will do combustion, even at very high temperature. But in absence of that cut supply, yes, Instagram beta, Snapchat, and everything is run by my team beta. I'm not using anything. I'm only using study. I'm a mathematician. I'm a researcher. So I'm just using all that social media. I'm not using. I don't have, seriously. I don't have time. Seriously, only WhatsApp means WhatsApp also very late. I'm seeing the replies and comment. All people are knowing about it. In classes also, if but student question exams, before exams, whatever question you people are asking, that I will be checking. So now look here. So nichrome does not burn even at higher temperature. The melting point of nichrome is 1500 degrees Celsius. Yes. Burst with a force when they are broken. Yes. Okay, bless you, beta. So that means what? It is burst with a force when they are broken. Nice, Vishwa. So now we are going to talk about what is the temperature here? 1500. 1500 is the temperature. And that's why heating element of electrical appliances are made with nichrome. Heating effect of what they are made with? Electrical appliances heating. Means specifically for heating purpose, what we are using? We are using what, beta? Nichrome. We are using nichrome, not constantine, not manganese. I hope everybody understood. Nice, Viswa. So now insulators are used. Where insulators are used? To protect ourselves from severe shock of electric current. And there now you might have seen that gloves and everything people are using. Why they are using gloves and all? Because they want to protect themselves from electric shocks. So that's what you might be seeing, that electricians are always wearing rubber gloves, correct na? And then they will be doing work. In fact, when they will reach a pole also, they'll be very quite what you call, they're quite cautious, because what you call, they can get electric shock. Yes, they can get electric shock. Now can we go back to our work, because most of the students, now we are going to talk about Ohm's law. Anybody have any idea about Ohm's law? See, what is exactly the case of Ohm's law? So here, when physical conditions like temperature, length, area of cross section remains the same, the current flowing through a conductor is directly proportional to potential difference. V is equal to IR at the end of the conductor. See, look here, beta, there is always some problem here in understanding. See, there is always some problem here is, come here, I will teach you. Okay, now listen, there's always here some problem in understanding. So what is the problem here in understanding is V is equal to IR. Now one question I am going to, potential difference is directly proportional to flow of current. Potential difference is directly proportional to flow of current. So now what we are going to understand with these conditions, one time you check. Now V is directly proportional to I, or I is directly proportional to V. Which one is more applicable? Let's see. Let's see. Which one is more applicable? V is directly proportional to I, or I is directly proportional to V? V is directly proportional to I, or I is directly, first one. Some are telling first one, some are telling second one. What is the correct one? First you say. What is the correct one? Huh? What is the correct one? Second one. Current is directly proportional to potential difference. Then why we are writing V is equal to IR? See, look here. Yes, the correct answer is V is directly proportional to current. Understood? Now, beta, you need to understand only one thing. The thing here is कि when we increase the potential difference, current also increases. This means this only. This means this only. When we increase the, understand this one, so increase in potential difference will increase the current amount. Understood? So increase in one factor increases the other factor. So increase in potential difference, absolutely. Okay. So increase in potential difference increases the current. Increases the current. That's the most important point. Increase in potential difference increase the current. Got it? So here we are going to understand this one. Okay, so V is equal to IR. Understood? So to remove proportionality, what we are putting? To remove proportionality, what we are putting, beta? To remove proportionality, we are exactly putting I. I is called as resistance. And this resistance is constant of proportionality. Constant of proportionality. What is this R beta? R is considered as constant of proportionality. Why? Because it is exactly put into the equation to remove proportionality. Proportionality is not equality. Remember this one. Proportionality is not equality, beta. Proportionality is not equality. Now, proportionality is not equality. So, to check this part out, once we are removing this section proportionality, we are putting R. R is what, beta? Resistance. What is R, beta? R is resistance. Everybody, are you all ready? Did you understood this one? Did you understood? Everybody understood this part or not? That what is V? V is directly proportional to I. V is directly proportional to I. Now look here again. Vishwa is telling he did not understood. Yes, Vishwa, I'm going to let you understand this part. Just 1 minute. One light is coming, beta. See, I'm going to explain this one more time. Wait. Now listen, what we are going to talk about, now look here. See, what I am explaining here is, see, once you are exactly connecting, check this one out, what I am speaking. Now look here. So once you are exactly connecting a circuit with combination of cells, that is called as battery. Okay, so here I am just going to put bulbs. So we just put bulbs here. Okay, now understand here. Now, how much is this potential difference will be there? Potential difference because of chemical reaction taking place. Chemical reaction taking place inside the cell. So this chemical reaction will generate a electromotive force, or it will generate, and with that electromotive force, the electrons will start moving from negative terminal towards, understood? Understood. So it is exactly going from negative terminal to positive terminal. So negative terminal to positive terminal, the electrons will move because of the electromotive force. That electromotive force is because of the potential difference. Understood. So now, right now, just we will take potential difference as 10 volt. Then current will move according to 10 volt only. Correct? Na? Now another circuit we have taken. Two bulb only, okay, two bulb only, but this time it is 15 volt. So which circuit is having highest capacity to drag more current? Whose electromotive force is higher? This electromotive force is higher, or this electromotive force is higher? Understood. Whose electromotive force is higher? Whose electromotive force is higher? The one who is having higher potential difference. Absolutely. The one which is exactly having, hello beta, the one which is having higher potential difference will be exactly having what? High amount of possibility of flow of current. I hope you might have understood. So 15 volt current will allow more current. So that means what? This is exactly explaining one factor. This experiment, this reading is only explaining one factor, that potential difference is directly proportional to I. Understood or not? That means if you will increase potential difference, what will increase? Current flowing in the circuit. If you will increase potential difference, what will increase? Current flowing in the circuit. Vishwa, did you understood beta? Did you understood this? So if you increase potential difference, it will increase what beta? Come on, say. Current flowing in the circuit. And to remove this part, what we are writing? R into I. R into I. Vishwa, everybody, please kindly understand this. This one, did you understood, beta? This part, did you understood? So, if you increase potential difference, current will increase. And to remove this proportionality sign, yes, absolutely. So, if I am going to remove the proportionality sign, exactly this part will come. I hope everybody understood this one. I hope everybody understood this one. Come on, we'll go for our work, please. Okay. Now listen, we will be going for the next part. So once we are going to talk about the next section, we are going to write about the next section. This is exactly about current. So now we are going to write. So what is the bigger unit? So what is the bigger unit of resistance? Usually resistance we are measuring where beta? So resistance we are measuring as 1 kilo ohm. Kilo ohm is equal to 10 to the power 3 ohm. Note down, 1 kilo ohm is equal to 10 to the power 3 ohm, and the next one, 1 mega ohm is equal to 10 to the power 6 ohm. Understood? So this is exactly the formula. 1 kilo ohm is equal to 10 to the power 3 ohm, and 1 mega ohm is equal to 10 to the power 6 ohm. Aditya, you are belonging to which class, Peter? We are right now teaching class 10. So it is belonging to which ohm? We are belonging to which ohm? Absolutely correct. 1 mega ohm is exactly equal to how much, beta? 1 mega ohm is exactly equal to 10 to the power 6 ohm. Absolutely correct, Vishwa. Absolutely correct. So beta, 1 ohm is equal to 1 volt by 1 ampere. How we wrote 1 volt by 1 ampere? Because we know one thing, and that most important thing here is that whenever we are going to talk about V is equal to IR, what is this is volt and current is ampere and resistance. So volt by ampere is equal to R. Volt by ampere is equal to R, and volt by ampere is equal to R, and that's volt by ampere is taken as ohm. Volt by ampere is considered as what? Ohm. Good morning. So volt by ampere is considered as what, beta? Ohm. I hope everybody might have understood what in all classes content we have studied. Okay. So we have studied all these sections. So I hope you might have understood this part. Are you all ready? So this is exactly the next section we are going to study, beta, because now we are going to go for the next study, next part. Okay. Yes, Sophia, since morning you were not, just now I saw your name. Monkey, again you are late. I want to teach you one thing. Now, what is the meaning? See, Ohm's law will be, now come on children, are you all ready for it? Now answer my questions. First question is, what is the restrictions of Ohm's law? What is the restrictions of Ohm's law? Come on, go for it, fast. Good morning, Sumit. So what is the restrictions for Ohm's law? And your time starts now. What is the restrictions for Ohm's law? What is the restrictions for Ohm's law? The restrictions of Ohm's law is it is applicable at constant temperature, length and area of cross section. So if yes, temperature must be constant, very good. Second is length and area of cross section also you cannot change. So that's what the Ohm's law will be applicable in that type of devices where you are not changing the temperature and length and area of cross section. I hope everybody understood this one. Come on, say. Everybody understood this part? Yes. Length and area of cross section. Why the answer started coming very slow? Yes. So now, beta, non-ohmic devices. Now we are going to talk about non-ohmic devices. Now let's check this one out. So if somebody will be asking you about ohmic devices, say exceptions of Ohm's law. In general, all metal conductors obey Ohm's law, that is V is equal to IR, which graph between V and I straight line. So 100% in this situation, when Ohm's law will be application is there, so V is equal to IR. V by I, and this is representing R. V is equal to IR. V is equal to what? V is equal to IR. Now, after that, what we are doing here is the conductor obey Ohm's law. However, there are some exceptions such as vacuum tube. What is the exception? Write down the exception. Vacuum tube. Second exception is semiconductor. First exception is vacuum tube. Please check this one out. Jotham, check this one out. First one is vacuum tube. What are the exceptions? Vacuum tube. Second one is semiconductor, diode, semiconducting conductor diode, transistor, liquid electrolyte, etc. This will not be whole good. So these devices are called as non-ohmic. What these devices are called as? Non-ohmic. So which and all are ohmic, beta? Which and all are ohmic? All the devices will be talking. Most of the metals, they will be following this ohmic law. But only some are not following. What are they? Semiconductor. Understood? What are they? Semiconductor. Second one is beta vacuum tube. Semiconductor and vacuum tube. Next one is transistor, liquid electrolyte. Semiconductor device, diode, yes, semiconductor, diode, vacuum tubes, and transistor, liquid electrolyte, wherever you are using. So they are exactly what? They are not, sorry, they are non-ohmic. devices. What they are? They are non-ohmic devices. What they are? Non-ohmic devices. And that time now, it will not be following V is equal to IR. They will not be following. The curve can be like this. Understood? So this is for non-ohmic devices. Non Understood. This is for non-ohmic, OHMIC, ohmic devices. So this is for whom, beta? This is for non-ohmic devices. So today you understood now which devices are called as ohmic devices and which devices are called as non-ohmic devices. So how was the session today, beta? Can you tell me? Was the session okay? Was the social session okay? You understood. Thank you for liking the class. Thank you for understanding and thank you for responding. It's so good. Okay. Yes, super. Maya, absolutely correct, beta. Today I also enjoyed because most of you have answered very, very nicely and you exactly responded nicely. Very good, beta. See, people will trouble you. Is it affecting me? No, so it should also not affect you. We are doing something good because these videos are very important. Publicly, we need these videos so that before exams, we will keep on revising with it. So, ohmic, non-ohmic, we studied graph also, we studied, and we studied some numericals. So, today evening also, you are having class. Very good, Vishwa. But some of the mind-blowing answers was given by you. So, first thing, see, today evening I am going to Trikalkundram. So, because I am going to Trikalkundram, so from there I will take class. So, that time it will be what, beta? Maths. Maths. Why? Because we have very less time, and from 1st of November, our slot is ready. For 5 days, our slot is ready. Test slot is also ready. So, all the slots are ready. So, we need to work according to our slots. Okay. Bye, everyone. Have a nice day. Enjoy. Hey, big day for me, yaar. You just need to give me wishes. You should say all the best. I'll tell you afterwards why I'm telling you. Bye, beta. Bye bye.